Okay, so in this video we're going to take a look at the solutions to class test number 5, which is on first order differential equations. So here's the very first question, and in this question we're asked to determine the general solution of the equation y squared minus 2 dy dx equals 4y. Now to do these questions we use the separation of variables technique. So basically what we need to do is need to get the variables, any variables x with the dx and any variables y with the dy. So at the moment we have a y squared minus 2 and a dy. So let's bring the y's all to one side. And if we do that, we rearrange and we get y squared minus 2 and the 4y comes down underneath the line. So dx equals y squared minus 2 over 4y dy. And now what we need to do is we need to get rid of the dx and dy. Basically we want to get everything in terms of x and y. So we integrate both sides. But before we do that, let's just divide y squared by 4y, which is y over 4. Y cancels, that y here cancels with this. And you'll have minus 2 over 4y, which is the same as 1 over 2y. Okay, so now we can integrate both sides. So if we integrate both sides, we integrate the dx, which is going to give us x. When you integrate the x, you always get x. And then integrate y over 4, add 1 to the power. So add 1 to y to the power of 1 gives you y squared. Divide by the new power, which is 2. There's already a 4 there, so this becomes y squared over 8. And now we have to integrate 1 over 2 times 1 over y. So remember, if you integrate if you integrate 1 over y, you get the log of y. So that's what we have here. So the half can come, so really we're integrating half times 1 over y. So when you integrate 1 over y, you get log. So the half comes to the front and we're left, the 1 over y becomes the log of y. And remember, because we've no limits or we don't know any conditions here, we can, this becomes what we call the general solution. Okay, so that's the general solution. That was the first part of the question. So let's go back there again. So I'll just change my pen. Okay, so determine the general solution. So that was part A, that wasn't too bad. So now let's have a look at part B. So in this question, we're asked to determine the particular solution of the equation. And to get the particular solution, we really need to get the general solution. And then we use the boundary conditions or the conditions that they tell us. That in this case, we're told that when y is 1, x is 0. Okay, so as before, we need to separate the variables. Get everything with dx and the x together and everything with dy and y together. So in this case, I've got a y squared minus 4 on the bottom and I've got a e to the 4x plus 1 on the top. So bring the y squared, that's y cubed minus 4, bring that to the other side. And you're going to get dy times y cubed minus 4, or y cubed minus 4 times dy. And then the dx comes up to the other side and you get e to the 4x plus 1 times dx. So now we have to get rid of dy and dx, so we integrate both sides. Okay, and when we integrate y to the 3, we add 1 to the power and we divide by the new power. So add 1 to 3, we get 4, divide by 4. 4 is just 4 times y to the power of 0. Add 1 to the power and divide by the new power, you just get 4y. Integrate e to the 4x. Remember, if you integrate e to the ax, you get 1 over a times e to the ax. So in this case, we just get 1 over a, which is 1 over 4. 1 over 4 times e to the 4x. Integrate 1, which is really x to the power of 0. You just get x, add 1 to the power and divide by the new power. So once again, this is what we call the general solution. And now what we need to do is get the particular solution. So you have to get the general solution first before you can get the particular solution. Okay, so we need to use the condition. We're told that when y is 1, x is 0. So anywhere we've 0, we're going to put, anywhere we've x, we put 0. And anywhere we've y, we're going to put 1. And that should give us an equation with just c in it. So 1 y to the power of 4 is 1 over 4 minus 4. But the e to the power of 0 is going to be 1. So you're going to get 1 over a quarter minus 4 is equal to 1 over 4. And if you bring 1 over 14 across here, it becomes minus 1 over 14. So minus 15 over 14 minus 1 over 14 is minus 16 over 14, and 4 into 16 goes minus 4. So we now know what C is, so now let's substitute that back into the general solution, and when you do that you get the following. So y to the 4 minus 4 over y to the 4 over 4 minus 4y is equal to 1 over 4 e to the 4x plus x minus 4, because C is minus 4. So this is in fact the particular solution. So that's how we get the particular solution. We get the general solution first, and then we use our condition to find C, and once we get C we substitute it back into the general solution. Okay, so that was part B. Now part C, we're told that the rate at which a body cools is given by this expression. The change in the temperature with respect to time equals K times theta. So it's really like having a question, dy dx is equal to, say, K or 8 times X, or 8 times Y. And if I asked you to find Y there, you'd bring the dy's and the y's together, so you get 1 over 8, 1 over Y dy is equal to dx. And then you would just integrate both sides and you'd be able to get the Y and the X values. So we do the same here. So this time we're told, so let's do part A first. So we'll just go to the next page and just simplify it first of all. So the rate at which, so we're given this, the theta over T equals K times theta, where theta is the temperature above its surrounding temperature and K is a constant. Show that the general solution is given by this. Okay, so let's take this expression here. Bring the T, you have to get the theta, the variables together, so it's going to be d theta over T, and d theta over theta is equal to K times dt. So if you cross multiply, you're going to get d theta, well that's what we start off with, so bring the theta down, so you get d theta over theta, and the dt goes to the other side, and you get that. And then we just integrate both sides. So once again, when you integrate 1 over anything, so this time it's 1 over theta, so when you integrate 1 over x, you get log of x. So in our case, we're integrating 1 over theta, we get the log of theta. Integrate dt, and you just get t. So it's like me saying integrate 2 times dx, you just get 2x. So 2 times d theta is dt is going to be 2t, or k times dt is just kt. Alright, so that in fact is, so that's the general solution. That's what we were asked to prove. So that's correct. So that wasn't too bad. Okay, so now the second part of the question, we have to try and find C and K. So let's have a look at that. So we're told the following temperatures are recorded. After 2 minutes, the temperature of the body is 60 degrees. And that really should say 60 degrees above ambient temperature, or above the surrounding temperature. So just go back to the original question there. I just want to check something. So back here, use the mouse to be quicker. Yeah, so the rate at which the body is cooled, so where theta is the temperature above its surroundings, and that's why I put in here, it should really say after 2 minutes the temperature of the body is 60 degrees above its surrounding, and after 5 minutes it's 50 degrees above its surrounding. So in this case, let's go back to that question. So so after 2 minutes above its surroundings, really what we need to put in there. So for both of those, it should really say that. Okay, so if that's the case, we have the general solution, and now we're trying to find K and T and C. So we know that when T is, the time is 2 minutes, so we're told that when T is 2 minutes, theta is 60. So we just substitute 60 for theta and 2 for T into the equation. And also we're told when T is 5 minutes, after 5 minutes, theta is 50 degrees above its surrounding temperature. So if we substitute, substitute when theta is 60, so put 60 for theta and put T is 2. So that gives us one equation. Then when theta is 50, put theta equals 50, and for T is 5 minutes. And then if we underline this and we subtract the bottom from the top, we're going to get the log of 60 minus the log of 50 is equal to 2k minus 5k, which is 3k, and the c's cancel. Okay, so log of a, just to get this, we can say that we could just work that out if we want in your calculator, but if you want, you could say the log of a minus the log of b is equal to the log of a over b. Okay, so in this case, we have the log of 60 minus 50. So what's that going to be equal to? That's going to be the log of 60 over 50, or if you want, it's the log of 6 over 5. And if you divide the log of 6 over 5 by minus 3, you get k is minus 0.061. So now all you have to do is put k into either of those equations, and we get the log of 60. So let's put it into this equation here, number 1. So the log of 60 is 2 times k, which is 2 times minus 0.061 plus c. And the log of 60 minus 2 times minus 0.061 is equal to 4.216, which is what you need to prove. Okay, so we have, so that wasn't too bad really, I don't think. So let's go to the last part. And the last part, it says, how long will it take the body to cool to 40 degrees? Again, it should say 40 degrees above its surroundings. It's kind of assumed that really. So now that we know what k and t is, we can write down the particular solution. So we know how this equation here allows us to find theta if we know t, or find t if we know theta. So what have we given here? How long will it take for the body to cool to 40 degrees above its surroundings? So we have theta is 40 there really. So substitute theta. So when theta is 40, you're going to get the log of 40 equals minus 0.061 times t plus 4.216. So you could work that, so we're trying to find t. So all you have to do is bring the 4 over here. So log of 40 minus 4 divided by 0.061. And that should give you 8.6 minutes. And that was it. So the only thing that was probably a bit confusing there was the theta is always measured above the surroundings. And that was I think that was the end of the question. Yep. Okay, so that completes the solutions for the class test. So hopefully you could go through that and see, well, obviously, first it's best to try it yourself first, and if you have any difficulties, have a look at the solutions.